Study Section 7, Introduction to Web Programming. Web Programming in JavaScript Client-Side. Introduction. In the previous study session, we explained CSS as a scripting language used to beautify out HTML. In this study session, we will learn how to use JavaScript on our website and the need to add the client-side scripting language to our website. Learning outcomes. When you have studied this session, you should be able to explain the usefulness of JavaScript, state where to include JavaScript in a document, understand the concept of variables, constant, operators, and functions, explain the terms, keywords, and cite examples. JavaScript. Rather like CSS rules, JavaScript can either be embedded in a page or placed in an external script file. But in order to work in the browser must support JavaScript and must have it enabled. Most browsers allow you to disable JavaScript. Bearing in mind that a user might not have JavaScript enabled in the browser, you should use JavaScript only to enhance the experience of using your pages. You should not make it a requirement in order to use or view the page. You add script to your page inside the script element. The type attribute on the opening script tag indicates what scripting language will be found inside the element. There are several other scripting languages such as VB Script or Perl, but JavaScript is by far the most popular for use in a browser. Here you can see a very simple script that will write the words "my first JavaScript" into the mypage.html. HTML body p script type is equal to text /JavaScript document.write my first JavaScript /script /p /body /HTML. JavaScript uses the write bracket method to write text into the document. Remember that methods perform an action /calculation. The text is outputted where the script is written in the page. Where you put your JavaScript within a page is very important. If you put it in the body of a page, as in this example, then it will run or execute as the page loads. Sometimes, however, you will want a script to run only when an event triggers. An event can be something like a key being pressed or a submit button being clicked. This is a particularly good option if your script is used by more than one page because you do not need to repeat the script in each page that uses it, and if you want to update your script, you need only change it in one place. When you place your JavaScript in an external file, you need to use the src attribute on the script element. The value of the src attribute should be an absolute or relative URL pointing to the file containing the JavaScript. For example, script type is equal to JavaScript src is equal to script /validation.js/. So there are three places where you can put your JavaScript, and a single XHTML document can use all three because there is no limit on the number of scripts one document can contain. 1. In the head of a page, this script will be called when an event triggers them. 2. In the body section, this script will run as the page loads. 3. In an external file, if the link is placed inside the head element, the script is treated the same as when the script lives inside the head of the document waiting for an event to trigger it, whereas if it is placed in the body element, it will act like a script in the body section and execute as the page loads. Some early browsers did not support JavaScript. Therefore, you will sometimes see JavaScript written inside an HTML or XHTML comment so that older browsers can ignore the script, which would otherwise cause errors as shown here. Newer browsers will just ignore this comment in the script element, script type, text to JavaScript, document.write, my first JavaScript, // angle bracket closed, angle bracket open, /script, angle bracket closed. Note how two / characters precede the closing characters of the XHTML comment. This is actually a JavaScript comment that prevents the JavaScript compiler from trying to process the brackets take 2, trying to process the angle bracket characters. Comment in JavaScript. You can add comment to your JavaScript code in two ways. The first way, which you have already seen, allows you to comment out anything on that line after the comment marks. Here, anything on the same line after the two / characters is treated as a comment. Script type is equal to text /JavaScript document.write, my first JavaScript, / comment goes here, /script. You can also comment out multiple lines using the following syntax, holding the comment between an opening pair of characters, ***, and a closing pair of characters, *// like so, ***. This whole section is commented out, so it is not treated as a part of the script, */. This is similar to comments in CSS. The NoScript element. The NoScript element offers alternative content for users whose browsers do not support JavaScript or have it disabled. It can contain any XHTML content that the author wants to be seen in the browser if the user does not have JavaScript enabled. Data types. Different types of data, letters, whole numbers, decimal numbers, date, are known to have different data types. This allows programs to manage the different types of data in different ways. For example, if you use the plus operator with a string, it concatenates two strings, whereas if it is used with numbers, it adds the two numbers together. Some programming languages require that you specifically indicate what type a variable is and require you to be able to convert between types. While JavaScript supports different data types, as you are about to see, it handles conversion between types itself. So you never need to worry about telling JavaScript that a certain type of data is a date or a string. A string is a set of characters that may include letters and numbers. Variables. Variables are used to store data. To store information in a variable, you can give the variable a name and put an equal sign between it and the value you want it to have. For example, here is a variable that contains a username. Username is equal to Bob Stewart. The variable is called username and the value is Bob Stewart. Note here that you need to use the var keyword only if you are creating a variable inside a function that has the same name as a global variable, although to understand this point you need to understand functions and global and local variables, which are covered later. A variable's value can be recalled or changed by the script, and when you want to do either of this, you use its name. There are a few rules you must remember about variables in JavaScript. 1. Variable names are case sensitive. 2. They must begin with a letter or the underscore character. 3. Avoid giving two variables the same name within the same document, as one might override the value of the other, creating an error. 4. Try to use descriptive names for your variables. This makes your code easier to understand and will help you debug your code if there is a problem with it. Assigning a value to a variable. When you want to give a value to a variable, you put the variable name first, then an equal sign, and then on the right the value you want to assign to the variable. You have already seen values being assigned to these variables when they were declared a moment ago. So here is an example of a variable being assigned a value and then the value being changed. var username is equal to Bob Stewart. Username is equal to Robert Stewart. Username is now the equivalent of Robert Stewart. Lifetime of a variable. When you declare a variable in a function, it can be accessed only in that function. As promised, you will learn about functions shortly. After the function has run, you cannot call the variable again. Variables in functions are called local variables. Because a local variable works only within a function, you can have different functions that contain variables of the same name. Each is recognized by that function only. If you declare a variable outside the function, all the functions on your page can access it. The lifetime of these variables starts when they are declared and ends when the page is closed. Local variables take up less memory and resources than page-level variables because they require only the memory during the time that the function runs, rather than having to be created and remembered for the life of the whole page. An expression is just like a mathematical expression. The values are known as operands. Operators that require only one operand of value are sometimes referred to as unary operators, while those that require two values are sometimes called binary operators. The different types of operators, namely 1. Arithmetic operators, 2. Assignment operators, 3. Comparison operators, 4. Logical operators, 5. String operators. Arithmetic operators. Arithmetic operators perform arithmetic operations upon operands. Symbol, plus. Description, addition. Example, x plus 5, where x is equal to 10. Result, 15. Minus. Subtraction, x minus 2 is equal to 8. Multiplication, x times 3 is equal to 30. Division, x over 2 is equal to 15. Modulus, division remainder, is equal to 1. Increment the variable by 1. This technique is often used in counters. X plus plus 11. Decrement decreases the variable by 1. X minus minus 9. Note that in the examples in the following table, x is equal to 10. Figure 7.1, arithmetic operators. The basic assignment operator is the equal sign, but do not take this to mean that it checks whether two values are equal. Rather, it's used to assign a value to the variable on the left of the equal sign, as you have seen in the previous section that introduced variables. The assignment operator can be combined with several other operators to allow you to assign a value to a variable and perform an operation in one step. For example, with the arithmetic operators, the assignment operators can be used to create shorthand versions of operators, as in the following statement. Total is equal to total minus profit. This can be reduced to the following statement. Total / profit. While it might not look like much, this kind of shorthand can save a lot of code if you have a lot of calculations such as this. See table below to perform. Figure 7.2 Comparison Operators. Comparison operators. As you can see in the table that follows, comparison operators compare two operands and then return either true or false based on whether the comparison is true or not. Note that the comparison for checking whether two operands are equal is two equal signs. A single equal sign would be an assignment operator. Figure 7.3 Arithmetic operators. Operator, description, example. Equal to. 1 equal to 2 returns false. 3 equal to 3 returns true. Not equal to. 1 not equal to 2 returns 2. 3 not equal to 3 returns false. Greater than. 1 greater than 2 returns false. 3 greater than 3 returns false. 3 greater than 2 returns true. Less than. 1 less than 2 returns true. 3 less than 3 returns false. 3 less than 1 returns false. Greater than or equal to. 1 greater than or equal to 2 returns false. 3 greater than or equal to 2 returns true. 3 greater than or equal to 3 returns true. Less than or equal to. 1 less than or equal to 2 returns true. 3 less than or equal to 3 returns true. 3 less than or equal to 4 returns false. Logical or Boolean operators. Logical or Boolean operators return one of two values, true or false. They are particularly helpful because they allow you to evaluate more than one expression at a time. The two operands in the logical or Boolean operator evaluate to either true or false. For example, if x is equal to 1 and y is equal to 2, then x is less than 2 is true and y is greater than 1 is true. So the following expression, x is less than 2 and y is greater than 1, returns true because both of the operands evaluate to true. String operator. You can also add text to strings using the plus operator. For example, here the plus operator is being used to add two variables that are strings together. First name is equal to Bob. Last name is equal to Stewart. Name is equal to first name plus last name. The value of the name variable would now be Bob Stewart. The process of adding two strings together is known as concatenation. You can also compare strings using the comparison operators you just met. For example, you could check whether a user has entered a specific value into a text box. There are three simple data types in JavaScript. 1. Number, used to perform arithmetic operations, addition, subtraction, multiplication, and division. 2. Any whole number or decimal number that does not appear between quotation marks is considered a number. 3. String, used to handle text. It is a set of characters enclosed by quotation marks. 4. Boolean. A Boolean value has only two possible values, true and false. This data allows you to perform logical operations and check whether something is true or false. This data allows you to perform logical operations and check whether something is true or false. You may well come across two other data types. 5. Null indicates that a value does not exist. This is written using the keyword null. This is an important value because it explicitly states that no value has been given. This can mean a very different thing from a string that just contains a space or a zero. 6. Undefined indicates a situation where the value has not been defined previously in code and uses the JavaScript keyword undefined. You might remember that if you declare a variable but do not give it a value, the variable is said to be undefined. You are particularly likely to see this when something is not right in your code. Keywords. There are several keywords in JavaScript that perform functions such as break, for, if, and while, all of which have special meaning. Therefore, these words should not be used in variable, function, method, or object names. The following is a list of the keywords that you should avoid using. Some of these are not actually used yet, but are reserved for future use. Abstract, boolean, break, byte, case, catch, char, class, const, continue, default, do, double, as, extends, for, final, finally, float, for, function, goto, if, implement, import, in, instance of, int, interface, long, native, new, null, package, private, protected, public, return, short, static, super, switch, synchronized, this, throw, throws, transient, true, try, var, void, while, with. If you are working on a page that contains more than one scripting language, in order to indicate the default scripting language, a meta element should be used in the head of the document. Meta http-equiv is equal to content-script-type content is equal to text/javascript. Function and function call. A function is some code that is executed when an event fires or a call to that function is made, and typically a function contains several lines of code. Functions are either written in the head element and can be reused in several places within the page or in an external file that is linked from inside the head element. There are three parts to creating or defining a function. 1. Define a name for it. 2. Indicate any values that might be required as arguments. 3. Add statements. If a function has no arguments, it should still have parentheses after its name. For example, logout. The calculate area function does nothing sitting on its own in the head of a document. It has to be called. In this example, you can call the function from a simple form using the onClick event so that when the user clicks the submit button, the area will be calculated. Here you can see that the form contains two text inputs for the width and height, and these are passed as arguments to the function like. The return statement. Functions that return a result must use the return statement. This statement specifies the value that will be returned to where the function was called. The calculate area function, for example, returned the area of the rectangle. Function calculate area width height area is equal to width times height return area. Some functions simply return true or false values. When you look at events later in the chapter, you will see how a function that returns false can stop an action from occurring. For example, if the function associated with an unsubmit event on a form returns false, the form is not submitted to the server. Practical tips for writing scripts. Before you start looking at the examples, there are a few practical hints on developing JavaScript that should save time. 1. Online script. Of course, some tasks will require that you create your own script, but if there is a script already written that you can use, then there is no point reinventing the wheel. You should consider just using that script. Here are a couple of sites that will help you get going, and don't forget, you can search using a search engine such as Google. 2. 1. www.authscript.com. 2. www.javascriptkit.com. 3. http://javascript.internet.com. Even if you do not copy the script exactly, you can learn a lot by looking at how someone else has approached the same task. 2. Reusable functions. Along with reusing other people's scripts and folders, you should also write code that you can reuse yourself. So, you should aim to make your functions as reusable as possible rather than tying each script into the one page. 3. Using external JavaScript files. Whenever you are going to use a script in more than one page, it's a good idea to place it in an external JavaScript file, a technique you learned about at the beginning of chapter 11. For example, in the image rollovers section, later in the chapter, you will see an example of a script that creates image rollovers for a navigation bar. Your navigation will appear on each page, so rather than including the image rollover function in each page, you can just include the one script into every page. This has the following 3 advantages. 1. If you need to change something about the navigation, you need to change only the one function, not every page. 2. The file size of the pages is smaller because the JavaScript is in one file that is included on each page rather than repeated. 3. You do not have to copy and paste the same code into several files. 4. Place script in a script folder. When you use external script, you should create a special script folder, just as you would an images folder. This helps improve the organization of your site and your directory structure. Whenever you need to look at or change a script, you know exactly where it will be. You should also use intuitive names for your script file so that you can find them quickly and easily. Form validation. Validation can happen in 2 places, either in the browser using JavaScript or on the server. The reason for the validation on the browser is that it helps the user enter the correct data required for the job without the form being sent to the server, being processed, and then being sent back again if there are any errors. It's much quicker to force the user to fix errors before submitting the form to the server. The server then double checks before passing the form data onto another part of the application. This second level of validation is performed because a simple wrong value in a database could prevent the application from running properly, and if the user does not have JavaScript enabled, then the application will not be compromised by the user submitting a value that has not been checked using JavaScript in the browser. Forms are usually validated using the onSubmit event handler, which triggers a validation function stored in the head of the document or in an external file that is specified in the head of the document, so the values are checked when the user presses the submit button. The function must then return true in order for the form to be sent. If an error is encountered, the function returns false and the user's form will not be sent, at which point the form should indicate to the user where there is a problem with what the user entered on the form. The onSubmit event will often call a function with a name along the lines of validate form or validate form. Because many forms contain several controls that require validation, you do not usually pass the values of each item you are checking into a validation function. The function is usually written explicitly for that form, although you can reuse the techniques you have learned in different forms, or even reuse entire functions for login or registration forms. The first task in a validation function is to set a variable for the return value of the function to be true. Then the values entered are checked, and whenever the function finds an error in what the user has entered, this value can be turned to false to prevent the form from being submitted. Checking text fields. You have probably seen forms on websites that ask you to provide a username and password, and then to re-enter the password to make sure you did not mistype something. It might resemble figure 7.1. In such a form, you might want to check a few things. 1. That the username is of a minimum length. 2. That the password is of a minimum length. 3. That the two passwords match. The validate function you are about to look at will live between the following script tags in the head of the document. Remember, if you were going to reuse the function on other pages, it could live in an external JavaScript file. Script type is equal to text/JavaScript in angle bracket /script in angle bracket. To start, the validation function assigns a variable called return value to true. If no errors are found, this will be the value that the function returns, which will allow the form to be sent. Then the form collects the values of the form controls into variables as follows. Function validate form. var return value is equal to true. var username is equal to from register text username dot value. var password from register dot text password dot value. var password 2 is equal to from register dot text password 2 dot value. The first thing you want to do is check whether the username is at least 6 characters long. If username dot length less than 6, return value is equal to false. Alert: your username must be at least /n6 characters long /n. Please try again. From register.text username.focus. The length property of the username variable is used to check whether the length of the username entered is longer than 6 characters. If it is not, the return value of the function will be false. The form will not be submitted, and the user will see an alert box with the specified error message. Note how the focus is passed back to the form control that has a problem using the focus method on this control, saving the user from looking through the form to find that entry again. You can also see from this example how the line break is used in the alert box to indicate breaks in the message presented to the user /n. If the code has gotten this far, the username and first password are both long enough. Now, you just have to check whether the value of the first password box is the same as the second one as shown here. Now, you just have to check whether the value of the first password box is the same as the second one as shown here. Remember that the exclamation is equal to operator used in this condition means not equal. If password1.value not equal password2.value, return value is equal to false. Alter your password entries did not match. /n please try again. From register.textPassword.value is equal to from register.textPassword2.value is equal to from register.textPassword.focus. You can see here that when the user has entered passwords that do not match, the user is shown an alert box with an error message reporting that the password entries did not match. Also, the content of both password inputs are cleared and the focus is passed back to the first password box. When the user makes a mistake with the password input, there is no point in leaving values in the password form controls because users will not be able to see the values they have entered into these boxes because it will show dot or asterisk rather than the characters. Therefore, users will have to enter both values again because they will not be able to see where the error is. The only thing left to do is return the value of the return value variable, which will be true if all the conditions are met or false if not. Return value. Here is the form that is used within example. Form name is equal to from register. Method is equal to post action is equal to register.axpx. On submit is equal to return validate this. In figure 7.5, you can see the result if the user's password is not long enough. Figure 7.5, validating text fields. Required text fields. Often, you will want to ensure that a user has entered some value into a text field. You can do this for an individual element using the technique you saw in the last example for the username. As you saw them, if users entered a value that was less than 6 characters long, they were alerted and the form would not submit. You can see this function working with a form that is very similar to the one in the last example, although the values for the name attributes have to be descriptive for the user and match the labels for those forms. Figure 7.6 shows the error message generated when the user has not entered a value for the email address. The word email in quotes has been retrieved from the name attribute of that text input. Figure 7.6 required text field. Preventing a form submission until a checkbox has been selected. If you want to ensure that a checkbox has been selected, for example, if you want a user to agree to certain terms and conditions, you can do so by adding a function to this onSubmit event handler, similar to those you have seen already. The function checks whether the checkbox has been checked, and if the function returns true, the form will be submitted. If the function returns false, the user would be prompted to check the box. Function checkbox my form. If my form.agree.checked is equal to false, alert you must agree to terms and conditions to continue. Return false, X, return true. Another common technique is to use script to simply disable the submit button until users have clicked the box to say that they agree with the terms and conditions. The following is a very simple page with a form. When the page loads, the submit button is disabled in the onload event. If the user clicks the CHK agree checkbox, then the submit button will be re-enabled. Body onload is equal to document.fromAgree.button submit. Disabled is equal to true. Form name is equal to from agree. Action text.axpx method is equal to post. I understand that this software has no liability. You can read on and on. Figure 7.7 Disabling form submission. You will not be able to submit this form unless you agree to the terms and conditions and check the terms and conditions box. Texting characters using text and regular expressions. Regular expressions can also be used to text patterns of strings entered by users. For example, they can be used to text whether there are any spaces in a string, whether the string follows the format of an email address, whether it's an amount of currency, and so on. This uses the text method like so. First, you set variables to hold the return value of true, the value entered by a user, and a value to hold the regular expression. Function validate form. var return value is equal to true. Var amount entered is equal to document.fromCurrency.textAmount.value. Var currency format is equal to /d plus bracket open /d curly bracket open 1 2 curly bracket closed question mark and /dot and comma. Then you text whether the value follows the correct format. If it does not, you allow the user give focus back to the correct form element and set the return value variable to false. If currency format is not equal to text amount entered, alert, you did not enter an amount of money. Document.fromCurrency.textAmount.focus return value is equal to false. Also read on and on. Here is the simple form to text this example. The following table that follows lists some helpful regular expressions that you can use to get you started. One, the technique simply will not work for those who have JavaScript turned off on their browser. While this is quite a small percentage, it does mean that those users simply cannot access those pages. 2. The technique tends to perform slightly differently on different browsers, and it's hard to get a script to work on all browsers. 3. Users can find it difficult to click the appropriate part of a menu that moves, especially if they have a disability or a sticky mouse. Hiding your email address. Several articles on the web that suggest you can use JavaScript to write your email address to pages using the write method of the document object to write out the email address rather than a normal A link and XHTML. The goal is to avoid getting so much spam. Among sources for spam are little programs that often go under the name of bots, spiders, or crawlers that crawl through websites looking for email addresses. These email addresses are then used as a target for spam. The problem with this idea is that anyone without JavaScript turned on in their browser will not be able to see your email address. A better alternative is to provide an email form that sends inquiries to you. Then, once you have received an inquiry, you can be fairly sure the user will not be doing this just to get an email address and that you are safe giving your email address to this user. Quick jump select boxes. Some sites offer select boxes in forms as a navigation menu, often referred to as a quick jump menu that takes you directly to different pages or sections of the site when you select that item from the drop-down list box. Some of these use scripts to automatically take the user to the selected page without the users actually pressing a go or submit button. Rather, the script is set up to dictate a change in the select box and then to take the user to that page. This is bad practice for two reasons. 1. You can use the up and down arrow keys to select items from a select box, and any user who tried to do this would automatically get taken to the first selection as soon as he or she pressed the down arrow the first time. Users would never be able to get further than this option using keys. While a savvy user might pick this up quickly, those with disabilities who are using keys rather than a mouse to navigate the site might be a lot more frustrated. 2. And again, if the user has JavaScript disabled, it simply won't work. Anything the user requires from your site. The bottom line in the decision on using JavaScript is whether it will simply enhance the user experience or whether it is required for the user to perform an action or see some vital information. You should never design anything that requires JavaScript in order to function. Remember the lesson from the disabling a submit button until a checkbox has been selected section. Study section summary. In this study session, We discussed that 1. JavaScript is by far the most popular script for use in a browser amongst other scripting languages such as VB or Perl. 2. Where you put your JavaScript within a page is very important. If you put it in the body of a page, as in this example, then it will run or execute as the page loads. 3. Variables are named memory location used to store data. The type of value a variable stored is called data type. 4. Keywords are reserved words that perform functions such as break, for, if, and while, all of which have special meaning. 5. The operator itself is a keyword or symbol that does something to a value when used in an expression. There are 4 types: arithmetic, logical, string, comparison. 6. An expression is just like a mathematical expression. The values are known as operands. 7. Validation can happen in 2 places, either in the browser using JavaScript or on the server. 8. The reason for the validation on the browser is that it helps the user enter the correct data. 9. Forms are usually validated using the onSubmit event handler. 10. One of the key things to remember, however, is that you should use JavaScript to enhance a page rather than relying on it to display content or offer some functionality. This is the end of study section 7. Thanks for listening.